Hello everybody. Today we are going to work on lesson 12-2. It's going to be graphing systems of linear inequalities. Homework for this lesson is going to be on page 445 in the textbook, and it's 8 through 22 even. So it's 8 problems and they are all graphing. So definitely 100% need graph paper for this homework assignment. So, what we've been working on throughout this entire unit lately is we've been working with systems of equations. So, what I want you to look at is this right here. Today we're not going to have systems of equations. They're still going to be systems because they contain more than one variable, okay, within your problems, but this is going to be inequality signs like less than or greater than or less than or equal to in all of your systems. So we need to do a quick review here of the fact that when you deal with inequalities, inequalities don't just have one correct answer. Inequalities have many, many, many possible solutions to them. So for example, if we were going to say, hey, what's the solution of y is less than or equal to 2x plus 3, it wouldn't just be one point. Okay? It would be anything on the line of 2x plus 3, or less than would be anything below that. So any point in this shaded region is a possible solution to that inequality. Same here, when we say y is greater than this line, we graph the line, but then anything greater than that is also part of the solution. So anything in this shaded region is a possible solution to this inequality. So when we think about systems, we need solutions that are going to work for both of the inequalities in the system. So what we'll be doing today is taking our graphing skills and our shading skills and taking two different inequalities, graphing them on the same coordinate plane, and that region where the shading for each inequality overlaps would be the area that shows where all the possible solutions are that would work for both inequalities in the system. So let's give it a try with one of the examples down here at the bottom. Okay, these grids did not copy super darkly, so sorry if they're a little bit difficult to read, but we'll get the idea. All right, things we need to remember about graphing linear inequalities. First, we're just going to graph it as if it was a line. It's in slope-intercept form. So y is greater than x minus 3 has a y-intercept at -3. So I'm going to put my y-intercept at -3. Okay, it has a slope of 1, or if you'd like to think of it as 1 over 1, that's fine. So we need a positive slope of 1. So I'm just going to continuously go up 1 over 1, best I can see on this grid. I'm going to go the other way also. And the other thing we want to review about inequalities real quick is it does make a difference whether or not there's that equal bar underneath or not. This one that just says greater than does not have the equal bar underneath, so this won't be a solid line. Okay, my solutions aren't equal to this line. They're just everything greater than this line. So this needs to be a dotted line or a dashed line, however you prefer to say it, but this should not be a solid line. And then we want to think of greater than and less than as above or below. If you see a greater than sign, you need to shade above the line. So if you were to put your pencil on this graphed line and say I need to shade above it, if you move your pencil upward, that would mean we need to shade on this side. So I'm going to say if you're kind of heavy-handed, you need to be real light. This is not my final answer. I'm just going to shade very, very lightly that this is the greater than side of this because this isn't finished yet. So all the possible solutions for the first inequality are here. Now we need to include the second one. For this one, my y-intercept is 6, so I'm going to start from 6. My slope in this case is -1 or -1 over 1. So we need to slant downhill, go down 1, right 1, until we get these to cross. And what's nice with the inequalities is you don't have to worry about whether or not they cross at an exact point because we're not giving the one solution where they cross. We have many solutions for where the shading crosses. This one does have the equal bar. So this one should be a solid line. Okay. And then again, we have the greater than or equal to sign. So again, greater means above. So if you were to put your pencil through that y-intercept right there on that solid line we just drew and move it above that, we would be shading on this side. Okay, so I'm shading kind of lightly so I can tell where the shading goes on each inequality now. So what I'm concerned about is if this side is shaded and this side is shaded, where are they both shaded at the same time? Where does the shading overlap? It's right in this area, and so we're going to darken that up, and this is where the solutions are that work for both inequalities. So this is what the graph of the solution would look like for this particular system. And then what's going to happen in the homework questions is once you get your graph completed, the homework is going to ask you to name 2 ordered pairs that are solutions and 2 ordered pairs that are not solutions. So we're going to practice that real quick. So basically, no one will write the same 2 answers down on their homework, I am sure. For the 2 solutions, you can pick any ordered pair that is in that darkly shaded region where the shading overlapped. So some that came up in class today is some people said like 6, 7. Okay, because the ordered pair 6, 7 would fall somewhere around here. That's within the shaded area. I had some people tell me 1, 10. Because the point 1, 10 way up here, that's within the shaded area. Okay, some examples of non-solutions could come from either this area, or the white space that didn't get shaded from either one of them. So I had some people tell me 0, 0 would be not a solution because it's not within that darkly shaded area. Some people went with some negatives down, like 5, -4 would be another example. 5, -4 down here. That's not part of the solution. So the first 4 homework questions are like this, where you will have 2 intersecting lines, there will be a shaded region, and you will name solutions versus not solutions. Okay, the other 4 problems on the homework all deal with parallel lines. So there are 3 different things that can happen with your parallel lines in a system of inequalities. So we're going to jump over to example 3, and we're going to graph this one out to let me show you the first thing that could happen with parallel lines. Okay, graphing the first one. The y-intercept is at -2. Okay, the slope is +2, or if it helps you out to write that as 2 over 1, you're going to go up 2 over 1 repeatedly. And this is a non-solid line. There's no equal bar, so you want a dotted line through there, not a solid one. And then we have to consider the shading. This is greater than, so if you were to put your pencil through that y-intercept and shade above it for greater than, that would be this side. I'm going to do that kind of lightly. Other one starts on 3. Again, it has a slope of 2. So, because they have the same slope, they will definitely be parallel lines. No denying that one. But what we tend to do, and this should be a solid line because it has the equal bar. What we're used to from our other problems is, ooh, parallel lines, no solution. Well, that's not true with inequalities because sometimes with the shading it will still overlap. Look at this one. This one says less than. So we should be shading below the solid line that we just did. So if I start at this solid line and shade everything below it, what we should notice is the shading did overlap somewhere, right in here. So darken it up. These are your solutions. Now what's going to happen is because with parallel lines, they're going to ask you, hey, on these parallel ones, show the graph, which we've done, and then they're going to say, describe the solution. So here's kind of a model you can follow for how you would describe the solution. They are wanting you to write something such as, all points between the parallel lines including points on y is less than or equal to 2x plus 3. So look at this description and make sure it makes sense to you. Okay, Yes, all the points in between these lines are part of the shaded region. They are all part of my solution. But that solid line means that it could be equal also to the points on that line. So it is all the points in between, including the points that are on this solid line. So if you have a solid line in your graph, this will be part of your answer. If these were just both dotted lines, you would say all points between the parallel lines, and it wouldn't be including either of the inequalities. But on this one, it is. Okay, so there is one thing that can happen with parallel lines. They might overlap in the middle, and you would describe it with an answer modeled after this. We're going to go ahead and flip to the back side of this page for a couple of extra notes and do two more examples of things that can happen with parallel lines. So this example right here came off of page 443 if you wanted to look at any others. But it's obviously two parallel lines because they have the same slope. But let's take a look at what happens when we actually graph and shade that one in. Top one, we're going to start on -3 as our y-intercept. Slope is -2, so down to right 1. I'm going to have to turn around and go the other direction to get my line a little bit lengthier. So here's my points. This does have the equal bar under it, so it should be a solid line. And it's a less than sign. Less than or equal means we would want to shade below this one. Okay, for the second inequality, my y-intercept is +1. I'm going to start up here. Slope is -2 again, so we'll have parallel lines. This one has the equal bar as well, so it will also be a nice solid line. Okay, and it says less than. So watch what happens. If I put my pencil on this line and shade below it, I would start my shading right here. Notice that doesn't overlap with anything yet, but when I keep shading below, it would continue on down here. So this time, the in between the parallel lines is not part of the solution because it works for this inequality, but not this one. But everything from here on down is an overlapping area of shading. So I'm going to darken this side up so it's clear that this is my solution space. And here is how we would describe that answer when your homework asks for it. We would say solutions are the same as y is less than or equal to -2x minus 3. Because it wasn't in the middle, it wasn't between the parallel lines this time. It was the same shading as what we shaded for this inequality. So this is what the textbook is looking for as a description when you have this situation. So we've looked at what happens when the shading overlaps in the middle. We've looked at what happens when the shading overlaps as one side or the other. And now we need to look at one more. So for this example, we're starting with y is less than 1/3 x minus 6. So my y-intercept is at -6. And my slope is 1/3. So rise 1, run 3. 1/3. Do a couple points in each direction. And that top one right there, that's a less than sign, so that needs to be a dotted line. So this one's going to go as a dotted line, not a solid line. And less than means below, so I want to shade below this line. Okay. The other one has a y-intercept of 5. 1, 2, 3, 4, 5. Slope is 1/3. So we're going to have my parallel lines again. This one's a solid line because it does have the equal bar underneath that greater than or equal to sign. And because it's greater than or equal to, greater than is above. So this time, if I were to say, hey, where does the shading overlap? It doesn't. So this is the situation where you get to write no solution. as your description. Okay, so there will be, like I said, 4 problems like example 1 that we did that do overlap somewhere. Name 2 solutions and 2 non-solutions. The last 4 problems will all be parallel lines, but your descriptions of them will be different based on which one of these examples that they look the most like. So good luck, make sure you have graph paper, and you can knock out lesson 12 too.